All right, for this problem, they want us to design a stack that supports push, pop, top, and retrieving the minimum element in constant time. So it's basically they basically want us to have a class that is like a stack, but in addition to getting the most recently inserted element in constant time, also the smallest element in constant time. So the trick for this problem is just going to be to use two stacks. So we basically want, in addition to just our regular stack, which keeps track of the uh, most recently inserted elements, we also want a stack which keeps track of the smallest element. So our our second stack is basically going to keep track of our smallest element. It's going to be exactly the same size as our regular stack, but basically instead of keeping track of the actual most recently inserted value, it's just going to have the smallest value thus far, right? So, and it'll be like the same. So hopefully that makes sense by the time like I've written all the code, and it's going to maintain the same size as the other stack. So, and then again, all of these are going to be constant time, all of these functions. So we need some state members of this min stack class. So I'll just use a vector. We could use just a regular stack as well, but just to show that this can be done with a vector, and stacks are also really just vectors under the hood. I'll just use a vector. So we'll have this is going to be our regular stack per se, right? So my stack keeping track of just the the most recently inserted elements, and then we also want one which is like the same size, except we're inserting the smallest element to that point in that stack. So we can insert to our regular stack regularly, right? So whenever we're pushing a val, this will be constant time. We'll just say my stack dot push back. Since it's a vector, that just puts the val. It'll make that the very last element in the stack or in the vector, right? So kind of like a stack. So we're just inserting to the stack, right? That's all we're doing for that stack. Now, for the min stack, we're basically going to be inserting the minimum of whatever val is or the top of the stack, right? So we'll say min stack dot top, and really that'll be back because it's a vector. But we can't just do that, right? Because min stack might be empty. So we actually have to check, right? If min stack dot empty, and this is a vector, so we'll just say min stack dot size greater than 0. Right, so if there is something to compare there, we can compare it, right, and insert. Otherwise, like, we don't even have to do the comparison, right? We can literally just say min stack, and there's a typo there, but we can literally just say min stack dot pushback val, right? Because there's nothing to compare. Okay, so this will be like a constant time push operation, and then our pop operation will just be we can always pop from both of those stacks. We need to make sure they're the same. So we'll say if my stack dot size is greater than 0, we have to do that check, because if we if there's no elements, there's nothing to pop. Otherwise, we can pop the parallel elements from both. So we'll say my stack dot pop back. That'll just erase the last element. We'll do that for both stacks. Okay, and then this is push back. back. Okay. And then that's going to be constant again, just removing that last element for the pop function. Okay. So for the top function, we basically can just get, we say if my stack dot size greater than 0, right? We don't want to try to access a value that doesn't exist, but if the stack does have elements in it, we can literally just say my stack dot back, or we're going to return that if it exists, right? And then you know, it'll complain, we'll just say return -1 if it doesn't exist, right? Because this is like an illegal thing. Return -1. So again, it's going to be constant, right? Just accessing the back element there after this check. So same for min stack, right? We know that min stack is going to maintain that smallest element in constant time. So that's pretty much it for this problem. Hopefully that helps. And I'll see you guys in the next piece.